Hello, good morning, students. On last lecture, we learned about the work done expression. Let's start the internal energy. Every substance is associated with its definite amount of energy. That is the bunch of energy. Energy stored in a substance. Substance means system, which is called as the internal energy. So we say that it is the sum of kinetic energy of all the molecules, ions, and atoms of the system. The potential energy associated with the force between particles, the kinetic and potential energy of nuclei and electrons in the particle, the energies associated with the existence of mass. In fact, we say that it is the grand total energy of the system or substance. When internal energy change, some or all of this contributing energy also get changed. In actual, the absolute value of internal energy is not known and it cannot be measured. The reason is, of course, that it is impossible to determine accurately most of the quantity that contribute to the internal energy of a system. So, it is not necessary to know the absolute value of internal energy of a system. For thermodynamic study, it is essential to know simply the change. Delta U in the internal energy is defined as delta U is equal to U2 minus U1, where U1 is the system energy in the initial state and that U2 is the final state. Although U1 and U2 cannot be determined exactly, delta U can be easily determined. All the applications in thermodynamics deals with only delta U and not with U. So, students, the internal energy of a system that can be changed, the energy is transferred in and out of a system as a heat or work. Hence, to know the delta U, it is required to monitor the energy supplied to or remove from the system as a heat or work. So, when the energy is transferred into the system by heating or doing the work on it is added to the system internal energy which increases. While on the other hand, when energy is transferred from the system by cooling it or by doing the work on the surrounding, it is removed from the internal energy of the system. So one thing is important, that the work and heat, they are equivalent ways of changing the internal energy of the system. It is immaterial whether the energy is transferred as heat or work or combination of both. It will cause the change in the internal energy, and hence the system can be considered as a bank and internal energy is the reserve. The system, we say that the bank can accept the deposit or make the payment in the currency either as the heat or work, but store it is the internal energy which is the reserve. The value of the bank which accounts depends on the reserve left after this the transaction and not on which the currency is used. Is it clear? So one example we take here, 30 kilojoule of heat is supplied to the system. It would be added to the internal energy of the system. Hence we say that here we use the delta U, not only the U. Delta U means total change in the system, either final to the initial. And now it's showing the plus 30 kilojoule. Because work is done on the system, it is added to the system. So plus 30 kilojoule. If we take that a system which releases 15 kilojoule of energy as a heat and does the work as the 10 kilojoule work on the surrounding, now this quantity of energy are removed from the systems. Internal energy which decreased by 15 kilojoule to 10 kilojoule. There is addition. When we put addition, of course we get the answer 25 kilojoule. Therefore we write there delta U is equal to minus 25 kilojoule, because quantity of energy are removed from the system. One thing is important, that delta U is always carry a sign even if it is positive. Is it clear? Let's start the next point. The first law of thermodynamics. There are total two laws which are included on the syllabus. That one first one is the first law of thermodynamics, which is a very important exam point of view. First we try to understand. It is simply the law of conservation of energy. What is that conservation of energy? Energy is neither created nor destroyed. Similarly, according to this law, the total energy of a system and its surrounding remains constant when the system is changed from initial state to the final state. The same law is stated in the different ways, but the meaning of all the statement is totally same, and the energy is conserved in all the change. So let's start to write the what is the first law of thermodynamic. The law state in different way. First is that the energy of the universe remains constant. Second, the total internal energy of an isolated system is constant. Third is similar to the law of conservation of mass. Energy is neither created nor destroyed and can only be converted from one form to the another form. In all total, according to this law, we can understand the total energy of a system and surrounding remains constant when the system it changes from initial state to final state. So we can say that all above statements are equivalent. The next one is the formation of first law of thermodynamics, how it can be formed. Now look here, as mentioned earlier that just we see the different ways of the laws of a system. They can exchange energy with the surrounding by transferring heat or doing the work. So what happened as a result, the transfer of energy as a heat or work, the internal energy of the system also get changed. Any energy supplied to the system in the form of heat and work which causes its internal energy also get increased. On the other hand, if we remove the heat or work from the system, what will happen? Yes, of course, the result in decreasing the internal energy. This argument can be used for deduction of mathematical equation of first law. So first try to understand what is that. Suppose a quantity of heat, we say it is the Q, is supplied to the system, and that on the amount of the work, that is the W, is done by the system, on the system by the surrounding. So obviously internal energy of the system will increase. Yes, thus increase in the systems of internal energy is equal to quantity of heat supplied to the system plus how many amount of the work done on the system by the surrounding. So we put there delta U is equal to Q plus W. So we write here delta U is equal to Q plus W, where delta U, that is this one, there is a increase in internal energy of the system, and this equation is the mathematical equation of the first law of thermodynamics. For an infinitesimally change, there is a different change in the quantity. The equation we can write like this: du is equal to dq plus dw. That change, the delta U, is it clear that it is the internal energy is totally depend on the heat and work on the system by the surrounding. So it is very important that the modification of first law of thermodynamics is also very important, but first law of thermodynamics, they can be explained for the various processes. Dear students, we already learned the different processes in the first lecture. So those students are not watching that video, please check it. Now first terms, that is the first process is the isothermal process. For the isothermal, once again we repeated, iso means same, thermal means heat, in which process the heat is constant, which is known as the isothermal. So let's start. Temperature is constant in such process. Internal energy of course get constant. So what we write there, delta U is equal to 0. How? For the isothermal process, value of Q is equal to 0, and if the value of, we put the value of delta U is equal to 0, is equal to Q plus W, that is W is equal to minus Q. This equation is implies that the heat absorbed by the system is entirely used for doing the work on the system, and hence when the work is done on the system by the surrounding, of course there is a result in the form of releasing of heat, and hence it's showing W is equal to minus Q. This equation is important because it's showing that the heat is absorbed, minus symbol, is showing that heat is absorbed entirely for doing some work on the surrounding, or that the work done on the system by the surrounding. So there is showing that the releasing of heat by the system. Second is the adiabatic process. In an adiabatic process, there is a no exchange of heat between system and surrounding. Therefore, Q is equal to now 0. There is a no any change. Therefore, what we get in the equation, we write that delta U is equal to W, or another term is what, minus delta U is equal to minus W. This equation is shows that the increase in the internal energy of the system is due to work done on the system by its surrounding, or that work done by the system on the surrounding. Due to the expense of the system, the internal energy will decrease in the process because it's showing the minus W symbol. When we substitute this value in particular formula, that is just we see in the mathematical equation of first law, delta U is equal to Q plus W. Next one is the isochoric process. So that definition we also learn, choric, in which it's showing the volume get constant. Now substitute this equation, that is W is equal to minus P external into delta V. If we write there the value delta U is equal to Q minus P Ex delta V external there. So delta U is equal to Q plus W. According to that, we substitute only the value of W. What we observe, if the reaction is carried out in closed container, then the volume of the system remains constant, delta V is equal to constant, that is we write delta V is equal to 0. In such case, no work is involved, and therefore the equation we get delta U is equal to QV. So the equation is suggests that the change in the internal energy of the system is due to what? Heat transfer at constant volume. The subscript V, which indicates constant volume in the process. As the U is the state function, QV is also the state function, and hence we see that increase in the internal energy of the system is numerically equal to heat absorbed by the system in constant volume. That constant volume which is known as the isochoric process. Now the next one is the isobaric process. Now you tell me, what is isobaric? Right, baric means here we say that the pressure is now constant. Most of the chemical reactions, they are run in the open container, just we had already told in the first lecture. So under constant atmospheric pressure, such reactions are occurred. In such reaction, the volume of the system is allowed to change, that is delta V is not equal to 0. In that equation, replacing the Q by QP, just we see, and delta U is by QP minus P external. So delta V in the equation, what we get? QP is equal to delta U plus P external into delta V, because the reaction is carried out in open container under constant pressure and very common which is in the chemistry. So in general in the chemistry, all the reactions they are mostly occurred in the open container. A special symbol delta H, which is called as the enthalpy change, which is given for the heat change produced by the reaction. So during the reaction, some heat changes is occurred, which is known as the delta H, which is known as also enthalpy change. Hence, in order to discuss the thermal effects for the reaction at constant pressure, it is conveniently to define a new state function which is called as the enthalpy, and hence the enthalpy change is given by symboling delta H, that is heat change during the reaction at constant pressure. So the remaining part, that is the most important part, enthalpy, that we'll see on our next part. Thank you.